everyone. My name is Imayath MOUSA-DJIBRIL. I'm currently working at UAC-FSA in Bénin, where I'm also involved in the local team of RTBfoods project activities, especially the activities related to the work package 1 and 2. Okay. I've been appointed to make today's presentation, which aim at understanding the relationship between the sensory texture attributes of boiled cassava from the instrumental texture parameters. To achieve this goal, 6 cassava samples for 4 cassava varieties were used. We have agric and dosi varieties, which were collected at 9 and 12 months old, and also Hombete and Ofege varieties, which were collected at 8 months old. So to each sample, the following experimental design was applied. We take 2 to 3 cassava roots with longitudinal slicing and steam cooking for 45 minutes. We're using water to cassava piece ratio of 2 to 3. So once the boiled cassava is cooked and ready to eat, we use it to do the sensory analysis through quantitative, descriptive analysis. And also we use it for instrumental measurement using the texturometer. So for the, all this experimental design was actually applied to one cooking batch of 1 sample. So we did it in triplicate, and we have 3 cooking batch for each samples. So for the quantitative descriptive analysis, 13 panelists were involved, and they helped us to generate 6 texture descriptors. And some of these descriptors were evaluated by hand. I mean, stick, hard to break, crumbly, and fibers, while 2 other descriptors, grainy and easy to chew, were evaluated in mouth. These 6 texture descriptors were evaluated using a 0 to 10 centimeter scale. So this is for the sensory evaluation. Concerning the instrumental texture parameters, we use 3 tests: the penetrometry test, the TPA test, and the extrusion test. And for each of these tests, each sample from 1 cooking batch, each sample from 1 cooking batch was analyzed in triplicate. So we have 3 assays for each test. So it means 19 assays, because 9 assays because we have 3 replicates at the instrumental measurements, and also 3 cooking batch for each samples. So especially for the protocol used for instrumental measurements, we use the protocol developed by CIAT for extrusion measurement on boiled cassava. And we apply the conditions recommended by the CIAT protocol, I mean, half cylinders of boiled cassava as a samples, and also the cassava fiber were placed perpendicular to the blade, as you can see in this photo here. One of the main conclusions of the protocol developed by CIAT is that extrusion was not suitable for non-Noncrumbly samples. Concerning the penetrometry and the TPA test, we used the protocol that have been developed at UAC-FSA, and these protocols were developed for boiling yam actually. So we just applied the condition defined already for boiled yam to the boiled cassava. Regarding the parameters measured for each of these 3 tests, for the penetrometric profile, we measure 2 parameters: the max force and also the energy, which is the area under the curve. For the TPA test, we measure the max force. We also measure the fracturability, which is the force measured at the first significant peak during the first compression. We also measure the adhesiveness, which corresponded to the negative area under the curve after the first compression. So for the fracturability and the adhesiveness, there is no data recorded for the factorability, no data was recorded for the Noncrumbly sample, while for the adhesiveness, no data were recorded for non-sticky samples. Concerning the extrusion profile, 5 parameters were measured. We have the max force, we also have the max slope, and the distance at max force. We also measure the extrusion force, which corresponds to the shear force recorded after the max force, and also the energy, which is the area under the curve. The extrusion force, for the extrusion force, we didn't have data for the non-Noncrumbly sample too, like for the fracturability measured by the penetrometry. So an overview of the main result that we obtained from the sensory analysis indicated that out of the 6 texture descriptors, only 4 descriptors, had to break, crumbly, grainy, and easy to chew, were allowed discrimination between the 6 samples of boiled cassava. And the mapping of the sensory texture attributes of the each of the 3 cooking batch used for the samples revealed that overall we have this PCA mapping show that based on the second axis, we have some repeatability in use regarding off-agar samples and also aggregate samples. Likewise, for dossier samples, we have a repeatability, but the best repeatability was observed with dossier 9 samples. For the texture parameters, we also check the repeatability of our data. Here is an example for 2 samples, aggregate 12 and dossier 12, which are recognized as Noncrumbly samples. So as you can see, overall, we calculate the coefficient of variation for each samples, and the extrusion has the lowest coefficient of variation, followed by penetrometry data, and the least one, the highest coefficient of variation will observed for the TPA data. So we can conclude that extrusion gave better repeatability, but remember that from the CIAT protocol, we know that extrusion is not suitable for the non-Noncrumbly samples. So we can recommend to use penetrometry test for boiled product, either Noncrumbly or not. We also check the discriminating characters of this method regarding our samples, and as you can see that in this table that fracturability and adhesiveness measured by TPA did not appear in this table. Likewise, extrusion force measured by extrusion is not in this table. It's because this sample, these parameters were not measured for non-Noncrumbly samples. So we just use the parameters that are similar, that we can measure for all these samples, either Noncrumbly or not. And the result of this table show that all texture parameters allow discrimination between all the boiled cassava samples, because you can see that the p-value is less than 0.05, but extrusion had the highest p-value, and which means that it's less discriminant despite its better repeatability that we saw before. Okay, so at the beginning of this presentation, I said that the main objective of this presentation was to understand the relationship between the sensory texture attributes of boiled cassava from instrumental texture parameters. So we try to show this relationship between sensory descriptor and instrumental parameter measures using the Pearson correlation test and also the multiple linear regression. We also use the partial least square regression to show the relationship between the texture parameters and also the cassava samples. So for the Pearson correlation test, we can, from the Christian correlation test, we can see that the descriptors thick and fiber were not significantly correlated with any of these instrumental parameters, while for the descriptor hard to break, crumbly, grainy, and easy to chew, that we were significantly correlated for the instrumental parameters. The max force here, as determined by extrusion, is not significantly correlated to any of the sensory descriptors. So except for the mass force, all tester parameters were significantly correlated to hard to break, crumbly, grainy, and easy to chew descriptors. The mapping of the tester sensory attributes with a tester parameters and boiled cassava samples show that max force determined either by TPA, penetrometry, or extrusion tests were associated to the descriptor hard to break and grainy, while only the distance at max force was associated with the descriptor crumbly and easy to chew. We try to predict the tester sensory attributes using instrumental parameters and using also the best model with two variables. We determine the best model with the R-square, which will be above 90%. So as you can see here, for the descriptor hard to break, max force determined by TPA can highly explain the hard to break descriptor. Also, the distance at mass force determined by extrusion contribute to explain the hard to break. So here is the equation that we get from these parameters. And this is only for an example for the descriptor hard to break. So for the other descriptor, crumbly, grainy, and easy to chew, we can see that the max force determined by TPA was the max force determined by TPA and distance at max force determined by extrusion were the main parameter that could explain the tester descriptor. However, between these two parameters, max force determined by TPA highly contribute to predict the texture sensory attributes. So, yeah. From this presentation, we can conclude that discrimination between samples were recorded for the descriptor hard to break, crumbly, grainy, and easy to chew. And also that irrespective of the instrumental tester evaluation method, max force can be used to discriminate boiled cassava samples. We observe a better repeatability with extrusion force, although a lesser discrimination was also found with these parameters, with this test. However, we think that penetrability test was more suitable for boiled products, either crumbly or not. The analysis method, the data analysis method used, Pearson correlation test, multiple linear regression, and partial least square regression were useful for understanding the relationship between sensory and instrumental tester parameters. However, we find some limits to our work, which is that fracturability and extrusion force cannot be recorded for non-crumbly samples. Likewise, adhesiveness cannot be recorded for non-sticky samples. The descriptor hard to break and crumbly are inversely related, but in this work, we didn't find any tester parameter that can show directly this kind of relationship. Also, other texture analysis, tester instrumental method exist, rheology that can be used to evaluate the texture of boiled cassava. And this method will also contribute to a better understanding of boiled cassava texture attributes. So our work should be continued to analyze the rheological parameters of the boiled cassava and to try to relate it to the sensory descriptor that we find in this study. So thank you for your attention. This is the end of the presentation. Thank you.
Thank you, Imayath. Well done, and we could hear you very clearly. So thanks for these very informative presentations in which you show well how you have built from shared protocols developed within the RTBfoods framework. And I am sure the approach you presented is of great interest to all Work Package 2 labs who will have to go through this process of translating sensory descriptors, and in particular those related to texture, into instrumentally measured parameters. So the next step is now to correlate these results with a range of acceptability of consumers to establish clear targets, quantitative values to inform the boiled cassava product profile. I see there was a discussion in the chat box between Thierry and Dominique regarding the possibilities to measure non-crumbly samples through extrusion. Thierry, do you want to share your feedbacks on this, your experience on this from CIAT?
Yes. Hello, Eglantine. Hello, everyone. Yeah, for non-crumbly samples, so that is hard samples. Actually, at CIAT, we haven't had problems to measure them by extrusion. With the cell that we have, that is 50 kilogram load cell, we haven't exceeded the maximum force. So I was a bit surprised that in the presentation, it seems that in Bénin, it was not possible to do it.
It's just a comment, I think.
Yeah. Yes. Yeah.
Okay, thank you.
Yeah.
Perhaps one of the reasons is cooking conditions, because in CIAT you are boiling the samples, and in Benin they are steaming the samples. Perhaps this can explain the difference.
Yeah. So maybe it may be harder because there would be less water absorption.
Yes. Yes,
Yeah,
perhaps.
that's very possible. Yeah.
Yes, and I want to thank Imayath because our presentation was very clear and very good. Yes, thanks.
Thank you.
Thank you.
There's a question from Christophe. Did you use samples for calibration and samples for validation to link sensory and textural parameters and to calculate the RMS? Do you have a chart to visualize and observe, observed and predicted data?
Yes, I can say a word. We don't use a sample to calibrate the test and method we use. As Imayath said, we only use the protocol used by CIAT and the one we develop on YAM. Concerning the RMS SE, we calculate it, but we cannot show it now because the presentation is done on my computer. They have data on the computer of Imayath and Laura. We can share this with Christophe later. That's what I can say. Christophe.
Yes, sir.
Do you understand me?
Yes.
We can share the cover with you and discuss with you.
Okay. No, it's just about, I was very surprised for the very good coefficient of determination
Yes.
Between the sensory attributes and textural parameters, very more than 90%. Yeah.
Yes.
I just want to see the chart to see the dispersion, the variability on your.
Yes.
Very good.
Yes, we can send it to you or discuss with you later.
Okay.
There's a question from Claire. Is there a possibility that some of these measures can be applied to raw roots to predict the texture quality of cooked or boiled or steamed roots?
To raw roots. I can say in my concerning my experience, I can say that only penetrometry tests can be used for raw root, but I don't know the experience of other colleague. I think that we can use penetrometry test for raw root. But what is his reliability? I can't say any word on it.
So Thierry has left.
From my
yes,
experience, just a point about this, I can say that I am not sure there is a correlation between the texture of raw roots and the texture of cooked roots.
Okay.
I agree with, I'm Didier from Côte d'Ivoire. I agree with Christian because the raw root will have always a higher level of force when we use penetrometers. So I think it will be very, very difficult to link this high value of forces with what's happened on cooking material.
Okay.
Thank you. Any other question for the team? I see no other question in the chat box. Some have been answered already. Dominique, you want to feedback on this prediction from raw roots with NIRS maybe?
Yes, the idea is to evaluate the spectral analysis on the raw roots and to find some correlation with these traits that are related to the sensory panel on friability, stickiness, and if there is some biological compounds in the root responsible of this friability, we expect to predict the cooking type at the end. This is just to calibrate the model for the spectral analysis. First, we need to demonstrate that we have a standard of operation for evaluating these traits. And this is the first phase.
Yes, I agree. And we are trying to do this evaluation in Guadeloupe, where we are doing texture evaluation and near spectroscopy of raw roots.
On YAM.
On YAM too, yes.
There's a question from Hakim addressed to Thierry and Dominique, but I suppose the Benin team could answer. Is there any relationship between fracturability, yes, and crumbiness?
Crumbiness of boy yam. Yes, if we don't analyze data in this point of view, if we want to see relationship between fracturability and crumbiness, we use only data from Crumbly samples. That is one point of view. We don't consider all the samples, but we take a subsample, the one which are Crumbly, and we can see the relation between fracturability and crumbiness. I think we will check it. We will check this relation. Dominique, we take into account your idea to see the relation between fracturability and crumbiness. this will do, because we don't have data for fracturability for non-Noncrumbly products, but only Noncrumbly products show some behavior of fracturability.
Yes.
We will collect this data and see if in among the Noncrumbly products we can see this relation between the two parameters.
Okay. And did you prepare sample for analysis of pectin and cell wall component between these?
Yeah, yes. With Christian, we plan to do analyze on pectin and
good.
cell
Good.
tint. Yes.
Excellent.
Okay.
Does someone want to ask a question or final comment to the team? I have one actually that has been raised by Dominique. How do you think you could share your preliminary results with the whole RTBfoods framework, with all partners? Because this is interesting what you've been presenting. So do you have any plan for publication soon? Or do you consider writing a brief report on this proof of concept, kind of proof of concept?
I think this is only a part of the work we did on the relation between sensory parameter and instrumental or biophysical parameters. We will combine all data and make a paper for this. And we want to analyze our data using a new statistical tools such as common component and specific wave analyze, which is a good static tool to analyze such data. So we plan to write a paper in this side.
Good to know. Let us know when it's published.
Okay. In this year, by September, I think.
Oh, that's optimistic.
Yeah.
Okay. Any last comments? No? So thank you very much, Imayath, for presenting on behalf of the team. Thanks, Noel and Laurent. Laurent, who answered questions in the chat box. That was a really good and very interesting presentation for the whole RTBfoods group. And thank you. And I've been asked by a lot of people how to access the presentation. So it will be on our RTBfoods YouTube channel. So should be by the beginning of next week. So it will be able, you will have the possibility to share this presentation with your colleagues who are interested.
Okay.
Thanks, everybody. We meet in 2 weeks for a presentation on sweet potato roots. The focus of the presentation itself is still still on the discussion with Suzanne Johan-Ningsmeyer from North Carolina State University. But it will be on the expertise of her team at North Carolina State University on the biochemical characterization of sweet potato roots. So thanks everybody for joining today's webinar. Congratulations to the team, and we see each other in 2 weeks' time. Bye bye. Take care.